Welcome everyone. Today we are starting a journey into one of the most fundamental pillars of computer science, the design and analysis of algorithm. Think of this course as the mathematics of problem solving, where we go beyond writing code and dive into how efficient, scalable, and smart our solution can be. So, let's start the class. Welcome to our first class on design and analysis of algorithm. Today we will kick off our journey into how algorithms play a crucial role in problem solving. So, what is algorithm? An algorithm is a clear and logical sequence of steps designed to solve a specific problem, just like following a recipe in cooking where you need to know what ingredients to use and the precise step to prepare a dish. Analogy with recipe. You can imagine the previous slide with this. Think of an algorithm as a recipe or delicious meal. You have your ingredients as the input, the cooking instruction, the algorithm itself. Then final dish is your output. In You can imagine a number of list and you can find the maximum number of there by sorting. You can use sorting algorithm to simplify your problem. Then you easily find the maximum number. In this slide, I already talked about the max finder algorithm. So, importance of algorithm. Let's talk about this. Efficiency of software. Algorithms are crucial because they define how efficiently software run. A good algorithm can reduce processing time significantly, learning to smoother performance and better user experience. For instance, an efficient search algorithm can reduce the time taken to retrieve results from second to millisecond. For example, if we use a bad algorithm, it take more time, it take more memory, then our cost will be increasing. But for a efficient algorithm, we can reduce time complexity. Also, we can reduce our memory space. It's definitely good for our any programming code or any other programming tools. So, multiple solution for a problem. When faced with a problem, there are often several algorithms that can be solved it. However, not all algorithms perform equally. Some might be faster or more resource efficient than others. This variability allows programmers to choose the most suitable program based on factors like the problem scale or available resources. We talk about this part in this course in next classes. Impact on scalability and performance. Algorithms directly affect how well a system can handle increased load as user number grow. A poor choice can result in slow response time and even system crashes. While a well-designed algorithm allows a system to process larger datasets without breaking a sweat, ensuring that performance remains stellar even under pressure. In conclusion, understanding algorithm is fundamental for anyone looking into computer science or software development. They not only dictate how efficiently algorithm can solve tasks, but they also help in making informed choice when designing software. With the right algorithm, we can build more efficient applications that scale smoothly.